Hello and welcome back to module number 13, and in this module I'm going to continue my previous discussion in module number 12 about the GUI of the interface, what is the user going to see when you're going to apply it to your programming that in Python and what it allowed us. So again, I'm going back a little bit just to make sure that everyone is have the ability to understand what we have discussed so far. We talked about the PWQT and our ability to create application which is a game, and we created that by using a class that we call peg game window, and we had the Qt widgets and the Q main window in order for us to do that. In that settings, I lay out the foundation to my window application and in order for me to apply to it. So the issue that now, and which is really important to me, is the layout management. So we need to talk about the layout, and there's two options that are being offered here: absolute position and layout class. Absolute position is as simple as calling the move, which method as a widget with some arguments that specify the position of x and y. And so we're going to see the application that might look differently on different application, or they will not scale back, and that can happen too. Secondly, we are going to see the changes in the layout that will be more huge with regard to how the class is being organized. So layouts classes are automatically position and resize the widgets to accommodate space, the change, so they will look and feel consistent. Consistent is the name of the game. One of the things that you are not allowed to do is to do freestyle. So the idea here is really important, that we will allow ourselves to have a structure using classes in order for us to apply to it. So every W widget subclass may have a layout specific to which they give the widget control over the position of the child widgets, the sensible default of the size of the widget, and the size or the scale of the window that we are applying to, and the resize of the handle of the application with regard to what it entails, and automatic updates when content changes. Example, Amazon uses that type of a layout when you make a purchase, so they know that already inside your basket there is someone who actually bought it. The issue now is that we're going to see it through Python's eyes and how it been applied. So the layout management in this case is there are a large number of layout classes, but the most common ones include box layout, grid layout, and form layout. All of it, again, you're not going to create a new office or a new Adobe Photoshop interface. It's going to be very simple. So again, a little bit cautious, but I think you will enjoy it. So box layout. So the Q box layout is a class which gives a child widgets horizontal or vertical layout. So it will give you space and divide it up to boxes that contain the widgets. So the Q box layout makes horizontal row of the boxes, and V box layout makes it vertical columns of the box. The box layout also create a box that attach it as an apparent widget, and allow and following method that I use to add a child widgets and manage the space. So add widget, you're going to have the ability to scratch it. In my default is usually equal to 0, but you can add the widget to the Q box layout and set the widget scratch factor. Another aspect is the add spacing, this size, to create empty box with a particular side. And add layout is to add a box containing another row and a set that layout scratch factor. So the scratch factor indicate the relative amount of leftover space that should be allocated to the block. Another aspect is the grid, and this is the most interesting, from my perspective, this is the most interesting aspect. So the grid layout is basically the most universal. It allowed us to use grid and box layout, and the grid represent with multiple rows and columns. The widget can be attached to the grid by indicate the row or the columns space it will fulfill with that. So to create a grid layout, you would use the qt widgets dot q grid layout, and you can specify exactly how it will look. Attach widget to the grid with add widgets can be another option. It's up to you to decide. You can also set the number of grid spaces that it should take up. So basically what you are creating is a basic layout, a basic grid. And so you have to have a class, you need to have definitions, and you need to, in the end, self-show in order for you to do that. So the recall of QMain window includes a default layouts for traditional GUI components like menu bar, a status bar, a toolbar, etc. And the focus point of the application store in the central widgets of the layout. So again, the class, or how I did that, is the class per game window, and set it up in the self.peg underscore game, and I will say self and self.pair game in order for me to lay out exactly how it will look. Let's really define this as the central widget should be look like. We will create a new class and we will call it per game in order for us to do that. So how it will look, again, it will look something like that. We will not, well, it's not very interesting, but at least they have important details that we need to do that. Now comes the layout of our grid in order for us to understand that, and it also gives us the board in order for us to, for the user to play. So in this case, I lay out for you the grid layout, the three components that it should have in order for you to have that, and how it should be defined and created in order for us to settle down with the grid. So again, we have columns, we have rows. My recommendation, recommendation is play with it. I cannot emphasize it again. Yes, it will take a long time to do that. But example, the row and the columns, play to see what it is. Make notes about what you have changed, so you will not stick in the middle and say, oh, I don't know what I have done wrong. So everything will be laid out for you, so you will have a sense what it is and how the width, the height also play a part of it. So again, this is the definition. And so we can, what does the pegboard looks like so far? This is the dimension that we are let it out. We created a class and we are using a Qt widgets and Q widget in order for us to do that. We define the self and the parent. We are defining the Qt widgets self parent, and we are trying to give some dimensions. So the parent we passed was that the peg game instance will hold the peg board. So the set fixed size method will give us a convenient way not only to define the size of the board instance, but also set up a layer that will give us a permanent container that we can apply to. Let's take, for example, a wood triangle. And so this, we need to introduce it as a Cube Painter object. So the Cube Painter is a class platform, low-level painting on any object that inherit the Qt GUI .QPaint device class in order for us to do that. So in order for me to apply that, I will use QP equal to the Cube Painter, and I will end up. So the most basic use involved creating the Cube Painter instance is called the beginning method with a device, so it will be painting and then calling the end of the methods. So we will start by using a collapse, and we use multiple settings: the font, the brush, the pane, in order for us to do that. And we also set font to set brush in order for us to define it. So the drawing will be draw alliances and be able to dream what you can do with that. Try it. That's the only thing that I can do, because right now we are not in face-to-face class, we are online. I would recommend you to do that. I will also post the entire code online, so you on Canvas, so you will be able to do that. So the Cube Painter is first thing is you notice is the method name we are using, paint event. So the paint event basically on the code onto your right is wherever the widgets appear is updated. That includes, we first show the widget, but we also requested an update. In this code that I presented before you is that we are creating a list of QPaint objects represented a triangle that we apply. So we can actually do that and apply that, and using those points we can utilize the Pentagon object by representing our triangle. And finally, we are creating the Cube Painter, make our board instance a Cube Paint device and draw the triangulation. So in this case, this is what it will do, and it will also help us to make two changes: get rid of the black outline and apply the wood grain fill into the space. So to grab the current Cube Pen object, we set up colors to transparent, as you can see in the code, and request Cube Pen object and create a Cube Brush object to set the texture of the image to a local picture of the same wood. So it will basically create a Cube Brush object in the end. So basically this is what we will have. So you want it to be black with a black background. Rather than drawing on the widgets, you can require us to change the way the widgets draw itself. So more specifically, we need to change the way the board widget display. One of the things that is really important is the idea of the GUI palette, and the idea it consists of color groups for each widget states. So it describes how the widget should render itself on the screen for each state. So you can do that by have consistent of 3 color groups: active, disabled, and inactive. All widgets in the container that you will have will use the platter to draw themselves. So the GUI widgets palette will method to return the currently used as an object and allowed us to reassign the object being used. So basically, for each state of the widgets, there are many rules which we can need to describe the feel and look. Each row has an assigned color and brush: the window, the background, the window text, the foreground, the bottom, and anything else that you're going to add. Colors and brushes are set a particular set rules in any color group within set colors. So for the color and set brush for color style and texture. So calling, for example, background row on the widget will return the current brush from the widget and then will draw its row. So you can actually do that and any other brushes on the background. How would you do that? Calling the template, and on the widgets object you will return it's currently associated with the idea of the GUI pattern, and the object method will be set colors, and it will allow us color row to be associated with the GUI color. So the set auto filling background will trigger the filling of the background, which is transparent by the default. How do I do that? The class pegboard together with the widgets and together with the QW widgets, and by doing that I will set up first of all the size, then I will set up the set colors in the 5th line with quotation, and will give some dimensions to the colors. This is part of your exploration and part of the idea what it is. One thing to remember, in the end the self autofill background has to be true and not false. So this is it. This is how I created the idea of a black background to our triangle. Adding to the board. Next, to add the peg holes to our board. Now we do not merely draw some dark circles on the board. We will create those objects containing that they contain the black holes. So the idea is, let's start with definition. We will start with the hole itself. So the class per hole, and we will define it. We will also define the event self and the event, and we will also define the minimum size hint, which is also part of it. So the idea here is that now we can use the place those things on the board, starting with the creating of virtual box layout on the board itself. So now we added 5 horizontal box layout to the virtual box background, and each horizontal box layout add a very stretch spacer. So the idea here is that each object will contain its space, and every scratcher spacer will be defined and be obligated. So it's not like free drawing, it will be more defined structure that we can apply to. The holes itself, in this case, it is what I created, and it will create a virtual box layout with a definition of set space method that allowed us to manipulate the margin between the widgets in the layout, and that's the code for that. In that case, I also applied the row in range and apply for in order for us to do that. And the next step is to create the object, and by doing that we are defining what is the object will entail. But just a note, in the last line in my code, it is self.peg equal none, and in this case it will allow us to control the manipulation on the code itself. We can also change the size to match the actual whole site, and we can create an event that, for example, the user go over the mouse in order for you to apply to it. We can also add another method to the whole class, which will allow us to associate instances with the object. So in this case, the definition to definition, and it will allow us to finally extend a board place hole method to associate with the page holes, and that's the code that will be associated. So this is basically what you come up with in the end. How about movement? That's part of the whole point, right? This is the hard part, and we are going to describe the mechanism of moving the pegs and how it interact with the game board. We're not going to be concerned with ourselves with keeping score, but yet if you want to do that, let me know. I will give you more reference to it. The most natural mechanism is probably drag and drop, and so we should be able to pick up the pigs and move them with the mouse and drop them into the empty hole. So the drag and drop commonly implement the idea behind the GUI interaction mechanism. So the idea here is that we are going to use an object called QDrag, and the QDrag class support the drag and drop transfer, and the idea is it can be applied to a multiple internet mail extension. Is a system server that apply to it. We are going to take it and apply it to do that. So there are two parts to the drop and drop action to be considered: the source and the target. Let's start with the source. And the source is really the essence of the whole structure. So the drag source is any object that creates the QDrag object when we interact with it. What does it really mean, interact? Well, we can define it in a couple ways. Here are some methods that we can override to start the drag. Mouse over event, and if you are familiar with JavaScript, this is a JavaScript basically event when we are using mouse over event, mouse release event, and mouse move event. These all three events are the classical JavaScript or web technology that often entail. So the drag source basically defines the class, the definition of the intel, and the idea of the mouse events when we are applying to it. So if there is no association with the object itself, it's simply called the basic mouse press event method and return to it. If there is a object, then it starts to drag and create a new object as a return for it. And the associate with the QMine data object, this is a requirement, but it is not requirement to hold anything significant during that time and use this source. So what is now happening? Well, not much, but it haven't defined what it looks like to drag the peg, and we have not defined any drop targets. The only thing that we can see for sure is the drag event starts when the peg hole has associate peg, otherwise nothing happens. So the drop target is where we are going to start the process. And since it is a conceptual, both the source of the peg and the destination, we will use the peg hole as a drop target. So the drop targets have the following property: self, the event, and the drop event. All of it part of any structure that we need to apply. So our new concept, drop request, will consist of self.setAcceptDrop and the grid of it, and the self layout and the self peg, which is also called none. And by drag event enter event, will create an event by itself with those premises that we are defining. So we accept the drop and add as a new object if there is not already an object associated with it. So now we can at least force a new object to appear, but it does not delete the old object nor describe what it means to drop from instance to another instance. So the drag sources basically allowed us to see the drag source, ability to have some control over the source itself, and ability to hide one of the object in order for us to be able to overcome it. And so when the drops happens, basically the check wherever drop was accepted or not. And if it's deleted, otherwise it will show again. So basically, once again, the drag and drop. We can also clean up a little bit the events itself and try to make it more accurate and more concise. But it will not be so nice to see the peg move. So we will create an icon of the peg and associate with the drag object in order for us to apply to it. And now the icon that appears in the peg looks like virtually. So it will be basically associated with the drag, and will also fill the object in the space. So drag and drops, and in order for us to do that. We also have a mechanism of movement. Now that we need to reinforce some rules that will comes down to two checks. Make sure the destination is valid, and make sure happened hole contains a peg to be removed. We are going to use the mine mechanism to send information about our drag source to our target, so we will help us to decide whether to accept or not. So checking this destination, we will first extend the class definition, and we will have a board maintaining a list of its child widgets and associate that they will encounter. And we will have this checking destination using the QMine data object that associate with the QDrag object that will pick up the string that holding the source. and we will only accept the drop request if the destination does not have a peg and the source of the drag is valid. With the reinforcement rules that I talked about, we are going to do that again. I'm using the if condition because this is the stronger way to enforce that. So I will say nope as none, and I will say if not, and I will say it a layout as if not or else. So reinforcement conditions or rules into it, and further readings about that, little bit a tutorial about custom widgets, and a little bit about a demo game that you might look at. So that's it for today. I hope you enjoy that. I'm sure that it will a bit too much, but I will share with you the code, the source code, and everything that I cover in this lecture. I hope it makes sense. If not, please let me know and I will answer any questions. Until next time, have fun and enjoy.